Hello all, I wanted to make a quick video to discuss the histogram. You can see the histogram looks a lot like a bar chart, however there are some differences. So a histogram is primarily used to show frequency distributions, frequency meaning how often numbers occur. So if we look at this histogram, we can see how often something between 60 and 70 occurs, how often something between 70 and 80 occurs, and it just counts how often those happen, and it allows you to see the shape of the data. So we can see by looking at this histogram, and it doesn't really matter what we're talking about, but we can see that right around 100 occurs the most. Now maybe this is points on a project, and maybe this is how many chocolate bars end up in a box, but the bottom line is we can see it's really close to 100 is, between 90 and 100, and between 100 and 110 occurs the most often, whereas it's pretty rare to get something between 40 and 50, or between 50 and 60, or even between 130 and 140. So it allows us just to see how often something happens. So you can see about 26 times between 100 and 110, whereas about 1 or 2 times between 40 and 50 is how often that occurred. That's the frequency distribution of what we're looking at. Now, how to make a histogram, and I'm going to go through these steps real quickly, but a little bit later in the video I'm going to show you how to actually make a histogram using real data, so I'll kind of bounce back and forth between them. First off, you get data, then you're going to square root the number of data points to get the approximate number of columns to use. Once you know how many columns you want to use, you're going to figure out the range of the data, and then just sort of divide those numbers to see what makes sense, how wide should the bins be. And again, if none of this makes sense, hopefully it will become more clear using real data and making our own histogram. From there, we'll determine the starting point for the histogram, which considers the bin width. Again, it's creating a histogram is more art than it is science. There's some general rules, but some guidelines that you have a little bit of play to determine how much you want to go with. And then finally, once we have the histogram, really the useful thing is we'll analyze it, and we'll look to see if it has a uniform peak, a single peak, or a double peak. And again, that's just sort of like looking at a mountain range or something. We can see this mountain range has 1 peak, this mountain range has 1 peak, this mountain range has 2 peaks, and this one doesn't even really have a peak, and that's known as uniform. It's just sort of stretched out, and it's even across the whole way. We would also want to see, once we've determined the amount of peaks, we would want to see if it's symmetric or skewed. Symmetric just means if you kind of put a mirror in the middle, does it have reflection symmetry? And you can see that this one kind of has reflection symmetry. This one also has kind of reflection symmetry. This one also has reflection symmetry. If you put a mirror in the middle, the left and the right look the same. However, this one doesn't have reflection symmetry. If you put a mirror in the middle, the right side is higher than the left side, so it doesn't really mirror, and there is really no symmetry there. That's what's known as skewed. This one happens to skew to the left. You can see the data sort of gets stretched to the left here. You can also see some where the data is skewed to the right, and it would imagine, it looks what you would imagine where the tail is to the right. Again, that's skewed left or tail left. If you sort of flip that and had it going off to the right, it would be known as a tail to the right or skewed to the right. So let's go ahead and make a histogram. So first thing it asks us to do is to get some data, and if we go over here, you can see we have some data. It's the daily high temperatures in degrees Fahrenheit. So the second step we would do is we would square root the number of data points to get the approximate number of columns to use. So if we go back over here and count up this data, it turns out that we actually have 31 pieces of data. So we'll go ahead and get the square root of 31. Go ahead and the square root of 31 is about, I should say about, it's not exact, 5.56, which means we would want to use about 5 or 6 columns. Again, it's not a hard, fast rule. We could use 4 to 7 columns. I probably wouldn't go too much less than 4 and too much more than 7, but we do have a little bit of play. But we're looking at essentially 5 or 6 columns. That's what the square root of the number of data points. Again, there's 31 pieces of data, square root, we're looking at about 5 or 6 columns. Now if we go to step C, it says determine the range. Well, it turns out that the smallest number in this data is 46, I believe. And the largest number in this data apparently is 72. So I'm going to go ahead and just get that range. And the range is 26. So between the smallest piece of data and the largest piece of data, I have 26 spaces, and I want to make about 5 or 6 columns there. So I'm going to divide them. I'm going to divide the data range by the number of columns that I want to use. And again, there's really no hard, fast rule here, but essentially, I'm going to divide about 26 by about 5.56, right? If I want to make this a 6 or if this is 25, whatever. But I get to determine, and I think 5 makes a lot of sense here. So I want to make a bin width of 5. Meaning that just like when I went over here, this original one had a bin width of 10. There was 10 bits of data and I counted how often it occurred. And then there was 10 bits of data and I counted how often it occurred. So my bin width in this example was 10. But in the one I'm making over here, I'm going to make a bin width of 5. And then the last thing I'm going to do is I'm going to determine my starting point. Well, if the smallest number is 46, and the largest number is 72, and I want to go by 5s, there's a couple things I could do. I could go 45, 46, 47, 48, 49, right? And then I can have a bin that goes from 50 to 51, 52, 53, 54, etc. I could say 44, 45, 46, 47, 48, and then I could go 49, 50, 51, 52, 53. So there's a lot of different ways that I can do this, and there isn't really a right way or a wrong way. It's sort of a personal preference. Now, the worksheet that I ended up having, and I think you'll see in a second after I erase all this, it chose this following bin list for me. It decided that it thought it made more sense to go from 40 to 44, 45 to 49, etc. Now, interesting thing about going from 40 to 44, if you'll remember, I said the smallest data point was 46. So there was nothing between 40 and 44. However, from 45 to 49, I have 1, 2, 3, 4 pieces of data. Between 50 and 54, I have 1, 2, 3, 4, 5, 6 pieces of data. From 55 to 59, I have 1, 2, 3, 4, 5, 6, 7, 8 pieces there. From 60 to 64, I have 1, 2, 3, 4, 5. From 65 to 69, I have 1, 2, 3, 4. And then finally from 70 to 74, I have 1, 2, 3, 4. So now I know how many pieces of data occur in each frequency. So I can go ahead and I can make my frequency table. So from 40 to 44, there's none. From 45 to 49, I have 4. So I'll do this as quickly as I can. It's definitely not going to look amazing, but I'll try and make it look okay at least. From 50 to 54, I have 6. From 55 to 59, I have 8. Uh, 60 to 64, I have 5. And then I have 4 for 65 to 69, and from 70 to 74. So my histogram is going to look something like this. Now again, yours might not look exactly the same because you might have had a slightly different scale, you might have had a slightly different bin width, but it should look roughly the same. Again, we wouldn't want to have 30 intervals to use here. We wouldn't want to have 2 either. We want to pick something that's reasonable, so that's why we went with the square root of the number of data points. And then the last thing we're going to do is we're going to go over here, like we said, and we're going to analyze it. Are we looking at no peaks, 1 peak, or 2 peaks? Well, I think I see one peak there. So I would definitely call this single peaked. The next thing I want to determine is if I think this is symmetric or skewed. And honestly, this data is a little bit tricky, I think. In a lot of ways, it looks like if you sort of drew a mirror down the middle, it definitely looks symmetric to me. However, we do have this one last little piece of data here. So I would say this is symmetric personally. However, as the season begins to change, maybe it moves more into summer and we start adding some days down here, well, then maybe we would end up with the skew. I don't think we're quite there with the skew yet, just because we have this one extra little column here. But I think that it's definitely worth considering that we could be heading towards a skew. So maybe if we did this again in a couple days or a couple weeks, we would see that it ended up skewing. But again, right now, I think I'm pretty comfortable calling this symmetric and single peaked. The other thing I wanted to show you was how to make one of these things in Desmos, which I think is pretty interesting to do. So it's kind of neat. You just basically say, hey, I'm going to name a list here and put equal. And then you just put the data in, and literally you just put the data in with commas. Now, I don't think you guys want to watch me do this, so I'm going to pause the video for a second and finish this up, and then unpause it and finish my histogram. I finished putting this data in. You can see the string. There's 31 pieces of data in there, so just what we had on the other sheet. Now, what I do here, it's very simple. I just type in histogram, and in parentheses I put L because this data list is named as L, so it made a histogram for me. But there's a couple of things I want to point out. First of all, we're doing ours based on count. We're not doing relative, we're not doing density, so leave that on count. However, our bin alignment, it's centered, so it's centered across 50. You can leave it that way if you like. I kind of like it if I click left. I just think that looks better, so it's kind of up to you. The other thing is the bin width. Now, you'll recall we went with the bin width of 5. It defaults to 1, but I'm going to change this to 5 here. So you can see that we get a really similar histogram to the one that we did over here, right? Whether we did it with Desmos or whether we did it just sort of making it on our own scale, we still get that single peak with the symmetric shape. Here's our single peak with the symmetric shape. So again, if you want to, you're free to use Desmos as well. Pretty simple process. You just name it a letter. I don't even think you have to use L. I think you can use whatever letter you want, and then just type the data in with commas. At the end, you put histogram. I would leave this on count. Personally, I like this on left, and then change the bin width to whatever you chose. All right. If there's any questions, feel free to reach out to me or Mrs. Baldwin.